Hello everybody, welcome to this initial review meeting. My name is Sayyidiptisam Tohidi and the title of my PhD project is High Performance Distributed Graph Analytics. So without further ado, let me begin this presentation. As you already know, graphs are ubiquitous in computer science. You see many real-life problems being formulated as graphs. For example, computer networks, social network, uh, roads, etc. Graph analytics essentially deals with the analysis of this kind of graphs. There are many applications of graph analytics. For example, there is classification. For example, an application of classification would be given a bank network. I would be interested in finding fraudulent users. Or there can be clustering. For example, given an IMDb data set, given the IMDb graph, I would be interested in clustering all the movies into a set and all the actors into a different set. And then there is this there is this problem of pattern recognition. In pattern recognition, I would be given a pattern graph and I have to find occurrences of the pattern graph in a larger data graph. So this is the problem that I am interested in, and this problem is also known as the subgraph isomorphism problem. Unfortunately, the subgraph isomorphism problem is a NP complete problem, and therefore no polynomial time algorithms are known. However, there are several approximate solutions and heuristic solutions. I am interested only in exact heuristics that solutions, and all the solutions that has been proposed in literature can be categorized under three heads. One is this state space search, this tree based search, which is the most popular example of this are the Ullman algorithm and the VF family of algorithm including VF2. There is constraint programming based algorithm, and then there is this graph index based algorithm. So the most popular, as I already said, are the tree search based algorithm. This uh, to a large extent, I am also interested in similar kind of algorithms, and these are the algorithms that are the most popular even in parallelized solutions. So when they parallelize this state space search, tree search based solution, they usually use a stack or a queue and a work stealing mechanism to handle the parallelization. So this kind of parallelization essentially comes under shared memory parallelization, shared memory system, but there are also distributed memory based solutions. Most of the distributed memory solutions use MapReduce, but there are non-MapReduce based solutions as well. For example, QFrag and S2. So using MapReduce gives you the problem of scalability, but not using MapReduce, for example, QFrag and S2, they also have their own set of issues. So yeah, this is all about this is a very high level overview of what are the solutions that are available in literature. My PhD project have three objectives essentially. My first objective is to figure out if they are given a pattern and data pair, graph pair, is there any characteristic of this pattern and data pair that will enable me to know which heuristic will work best at which stage of the search. So aim here would be to create a system that can dynamically choose the best heuristic during the search process to give me a very good to give me some kind of a speed up compared to the solutions that are available in literature. My second objective would be to propose a new heuristic that uses a vector based embedding of the nodes. Right now, the solutions that are available in literature, they use uh, values, some kind of scalar quantity characteristic of the graph to direct their heuristic search. For example, Ullman uses degree of nodes. We have two uses, neighborhood as well as degree. My idea is that if I use a vector-based embedding, I would be able to encapsulate more information compared to the scalar quantities characteristics, and because of this higher amount of information I would be able to do correct mapping early on in the mapping process, and this would help me save time because of the lack of backtracking that I would have to do because of this correct matches early on. So that is the idea behind objective 2. My objective 3 would be to apply parallelism in the satisfaction of objective 1 and objective 2. Now, when applying parallelism, I would face issues like load balancing, synchronization, communication, etc. When using shared memory system. Now my aim is to use a shared memory system, but if I use a distributed memory system for some reason, then I would also have to address this issue of cache coherence. So these are the kind of issues that may arise out of attempting to parallelize uh, uh, solution to objective 1 and 2, and I would have to handle these issues. Then I have this work plan. By differentiation, I hope to begin my experimentations, and by the end of first year, I hope to wrap up my experiment towards satisfaction of objective 1 and write up a conference paper. Then there are further objectives, as you can see, the deadlines along with the work plan is given on the screen. So this is everything in my presentation. Thank you for watching this presentation. Thank you.